Good morning, children. Welcome back to ICAN Physics. Now, in the fourth session from the second lesson, we are going to solve resistance, resistors in series, and resistors in parallel and related problems. Okay? Enjoy the class. Okay, so what we have studied, that is the reciprocal of resistance, that is N A E squared tau by M L. So now reciprocal resistance R equal to M L by N A E squared tau. So this is the expression for a resistance, but we know that B equal to I R. So R equal to B by I. Okay. So both are the resistances. We are having different expressions. So by using these expressions, what we can study? Resistance is directly proportional to potential difference. Okay. Next, the resistance is inversely proportional to current. Okay. So here we can go. The resistance is directly proportional to mass, is directly proportional to length, but inversely proportional to area. Inversely proportional to area. And inversely proportional to relaxation time. So now I want to see this one. So later we are going to discuss one problem. That is, in America, they are giving a potential of 120 volt. But in India, the voltage is 240 volt for domestic purposes. It's in USA. It's in India. Here, the voltage is high. Voltage is high. So, when the voltage is high, automatically the resistance also high. Okay. So, in later, when we are discussing the same problem, then I will ask the same question. So, where already we have discussed this word. Which one? In USA, we are having 120 volt. Then in India, 240 volt. So, by using these two values, we can say when the voltage increases, the resistance also increases. Okay. Then I am directly go to the last one. The resistance is inversely proportional to area. So when the area increases, then automatically the resistance decreases. Where we are going to see in meter bridge. In meter bridge. The meter bridge consists of 3 copper strips like this. Okay, it consists of 3 copper strips. Okay, so 1, 2, 3, 4, 5. The two ends of the copper strips are connected by means of 1 meter long manganese wire, which is fixed on the wooden board. Here we are using 3 copper strips. Why we are using 3 copper strips of this much of area? So when the area increases, automatically the resistance decreases. So when the resistance decreases, the conductivity also increases. So for that purpose only, we are having copper strips in meter bridge. Okay, do you get it now? Do you have any doubts? Okay, no doubt. Okay, so B equal to I R. Okay, now the potential is taken along x-axis and the current can be taken along y-axis. Then the graph will be a straight line. Why? Because the V is directly proportional to I. So when the potential increases, then the current also increases. So it's a graph for conductor. It's a graph for conductor. Okay. Then we are going to see about a graph which the voltage is taken along x-axis and the current is taken along y-axis. Then initially the graph will be 0. Then gradually it increases. After reaching a particular point, it goes to the maximum. Okay. So why it is initially 0? Then after that it goes to the knee voltage. Knee voltage. This voltage is called a knee voltage. Then after that there is a rapid increase of current. For which case? For semiconductor case. For semiconductor case. So why the graph is like this? Then we will study detailedly in the lesson. Semiconductor devices. Semiconductor devices. In that lesson, we will see detailedly. Okay. Okay. So when the resistance are connected in series, the resistances are connected in series with the external source. So from the source, the current is flowing. Okay. So when the current flowing through the first resistor of resistance R1, second resistor of resistance R2, and the third resistor of resistance R3, then the current will be same. The current will be same. Then there is a voltage drop across the first one, V1, and the towards the second one, and it will be the third one. So, which given by the source, the total voltage. So, the total voltage V equal to V1 plus V2 plus V3. So, when the resistors are connected in series, then the effective resistance is R1 plus R2 plus R3. Okay. On the other hand, when the resistors are connected in parallel, 1, 2, 3. Okay. So it is connected with the common terminal with the battery. So in this case, the potential will be constant or same. Now the resistance is R1, R2 and R3. From the battery, the current is flowing. When the current comes to this terminal, then it splits and flows in 3 arms as I1, I2 and I3. So in this case, the current will differ. I equal to I1 plus I2 plus I3. Okay. So here the voltage is constant, but the current will be different. But what about the effective resistance? That is 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. Okay. Do you get it now? Do you any doubts? No doubt. Okay. So by using current, so we are able to go up to this level. Okay. So in later, we are going to see about Kirchhoff's first law, second law, that also deals with the current. And in Wheatstone's bridge, that also deals with the current. So these are all the things that deals current. Okay. So now we can recall the question. So what is the charge? Charge equal to 60 coulomb. Okay. Now, what is the time taken? 2 minutes. Then, what is the current? So, what is the formula? I equal to Q by T. So, Q is 60. T is 2 minutes. 2 minutes. Convert the minute into second. 2 into 60. So, 60 cancel. 1 by 2. So, 1 by 2. Answer is 0.5 ampere. Okay. Suppose they are asking, what is the value of N? What is the value of N? So we know that I equal to Q by T, but Q equal to NE. So for instead of Q, we can substitute NE by time, that is equal to I. Okay. So now the division time comes to this as multiplication. Multiplication E comes to this as division. So I T. So the multiplication E comes to this as division E. Then the time T equal to I. So what is the value of I? 0.5 into time. So what is the value of time? 2 minutes. It is 2 into 60 divided by E. 1.6 into 10 to the power minus 19. So simply we can write it is 1 into. Are you able to remember what is the value of 1 divided by 1.6 into 10 to the power minus 19. That is the first lesson, first question. That is, it may be Q equal to NE, N equal to Q by E. So what is the value of Q? 1 coulomb. So 1 coulomb divided by 1.6 into 10 to the power minus 19. That is 6.25 into 10 to the power 18. So for instead of this one, we can write 6.25 into 10 to the power 18. So 1 0, we can get 1 decimal point. Okay. Now 2 5s are 10. So 10 into 6, 60. So into 60. So for instead of 1 0, we can bring 1 decimal point. So 62.5 into 6 into 10 to the power 18. So 5 6 are 30, remainder 3. 2 6 are 12, 12 plus 3, 15, remainder 1. 6 6 are 36 plus 1, 37. So how many decimal point? 1 decimal point into 10 to the power 18. So what we calculated? N. Sorry, it's N. So this number of electrons is flowing for the current of 5 ampere in 2 minutes through a 60 coulomb of charge. Okay. Do you get it now? Do you have any doubts? No doubts. Okay. So the same question they will ask. The area of the conductor is 2 meters squared. Then what is the current density? What is the current density? Okay. So J equal to I by A. Now what is the value of I? 0.5. 0.5 divided by area. Area is 2 meters squared. So 1 by 2 or otherwise 1 2 is 2. 0.22 are 4. Remainder 1. 5 2 are 4. 0.25 is current density. The unit of current density is ampere per meter squared. Ampere per meter squared. Now J vector equal to I cam plus J cam plus K cam. A vector equal to 2 I cam plus 3 J cam plus 4 K cam. Then calculate the value of current. Okay. So I equal to J vector dot A vector. Okay. Now J. So what is the value of J? I cam plus J cam plus K cam. Now dot product of A. So 2 I cam plus 3 J cam plus 4 K cam. Okay. So dot product. In dot product, what is the property we are having? I cam dot I cam equal to J dot cam dot J cam equal to K cam dot K cam equal to 1. So that we can multiply 1 into 2, 2. 1 into 3, 3. 1 into 4, 4. So 4 plus 3, 7. 7 plus 2, 9. So I equal to 7 ampere. So this will be the answer. Okay. Now do you have any doubts? No doubts.